Hello, Assalamu alaikum. Yes, my name is Ms. Razi Japan, and our today's topic is what prefixes. So today we will discuss about prefixes. So first of all, I will say you that why we consider prefixes in our physical quantities, because to represent physical quantities and to represent the amount of it, we use the numeric values. For example, if we are discussing, for example, the distance between any 2 points, we can say that the distance is, sometimes we say 10 meters, sometimes we say it is what, 100 kilometers. Sometimes we can say that the distance, if we will discuss about the distance between the countries, so the distance increases to a very large values. For example, maybe it increases 1 million times of a meter, and sometimes it is much more than that also. For example, if we'll just say the distance between the earth and the moon, so it is much larger the distance between the countries. So we'll represent that distance, of course, in the form of what? Numeric values. So if we have a large numeric value, so in order to write that numeric value in a very large number, so it is very difficult to memorize that number. It is difficult to write every time that number. So for that, we will use prefixes, because prefixes basically what? They will reduces the number of digits. How they will reduce, we will see, okay, later. Similarly, if we have very small value, for example, if we will say that in our human body we have what? We are composed of cells. If you will, I ask you, can you tell me the diameter of your cell? So it is so small, like I'll say that it could be, you can answer it me in nanometers, for example. So nanometers is basically a prefix that is used to represent very small distance. It's a very small value. So in order to represent the smaller values, we also use prefixes. Okay. So for the physical quantities that needs to represent in a very huge value, we will use prefixes to represent it in a better way, to write it properly, and to don't memorize a very large number. So that's why we use what? Prefixes. So basically the definition here is what? Prefixes are basically, it is the convenient way. It is basically what? It is the convenient way to represent the physical quantities. Either they are very big or small. That we have discussed here, okay? Now, for example, the example is given here. When measuring short distances, such as, this is what? 1 upon 1 billion of a meter. Okay, this number is what? 1 billion. That is 1,000 times 1,000. So it is what? 1 billion. So 1 billionth of a meter is basically what? You can represent in the form of prefix as 1 micrometer. Okay, this is what? 1 billionth of a meter. So 1 billionth of a meter is very short distance. So to represent that short distance in a convenient way is to use a prefix. So for the prefix of 1 billionth is what? Micro. So we use the prefix here is what? Micro. So that's why we use here what? Micrometer. So 1 billionth of a meter, basically how we can represent it mathematically. If you will look at here, so this is how we write 1 billionth of a meter. Okay. So if we have this, so how many zeros it has? We can write it like this: 1, 10 power, because it has how many? 6 zeros. So you can write it down as 10 power 6. And if we'll move it in the numerator, then the power of 10 becomes negative. So it will become what? 10 power minus 6 meters. And this 10 power minus 6 actually represents which prefix? It represents actually micrometer. So the symbol for micro is what? Mu. This is mu, basically it is the symbol for what? Micro. So here we write, in place of 10 power minus 6, we will write micro. So it will become what? 1 micrometer. So this is how we are representing in the form of prefix. So the physical quantity basically here is what? 1 billion of a meter, which we have mathematically represented in the form of 1 into 10 power minus 6 meters. And then this 10 power minus 6 is basically replaced by a symbol of micro. So in this way, we are able to represent this physical quantity in micrometer. So that is equal to what? 1 micrometer. And this basically, it is because it is in power of minus 6. So this is called as what? Sub multiple. Here it is written. Okay. This is called as what? Sub multiple 10 power minus 6 micro. Now when we are, this is for small distances that we have done here. Now if we have very long distances, for example here we have written how many zeros? 3, 6, 9, 12. So this is called as what? If you write in numbers, so it is basically 10 trillions. I'll say if you understand it. So this is actually what? 10 trillion meters. Like if you in numbers you have discussed about hundreds, thousands, million, billion, and then trillion. So this number is actually equals to what? 10 trillion. So it is what? 10 trillion meters. But this is a very difficult way to write because to write this number every time, so it seems difficult for us, and to memorize it is also difficult. So for convenience, what we'll do, we will replace these number of zeros with the prefix of tera. So here we have a prefix called tera, and in symbolic form this tera is represented by capital T. So if we'll write this in symbolic form, so it will become what? 1 terameter. So it's mean tera has how many zeros? 12, because we will count it. So here we have how many zeros? 12 zeros. So tera actually 10 power 12. This is the mathematical way they are representing here, that how we can write, because we have 12 zeros here. So in exponential form, how we will write? 10 power 12. So 10 power 12 is basically the multiple unit, and this multiple is replaced by a capital letter T, that is actually what? Tera. So what we'll say it, if we'll put tera here, we'll say terameter. It is basically what? 1 terameter. So now it is easy to write 1 terameter instead of writing 12 zeros here every time in our calculations. So it becomes more simple to understand. So that's why we use prefixes. So T represents the multiple 10 power 12. And for negative values, 10 power, like for example here minus 6, so it is called submultiple. And for positive values, it is called as what? Multiple. Clear? Now we have some prefixes here. So here we are going to, I'll show you the table here. These are the common prefixes that we use in our physics. Number 1, if we'll discuss about the multiples. So for factor 12, as we have discussed here, 10 power 12 actually represent what? Tera. For tera, the symbol is what? Capital T. Like we have written here terameters. Similarly, for 10 power 9, like if we have any numbers that is written in 9 digits, so we can convert it into what? Giga. So that is called as what? Giga, and it is represented by capital G. For example, if we can also write 2 gigameters, okay. For example, of now, right, we have the next is what? 10 power 6. This multiple and this multiple, 10 power 6 is equals to the prefix mega, and it is represented by capital M. For example, if I can say that we have the power is, we know that electrical power. So some electrical power is equals to what? 9 megawatts. Okay, so that is basically what? Megawatts. So that is what? 9 megawatts power. So if we'll write actually, so it is basically written as 9 into 10 power 6, and a complete number we can write how many zeros will put here? We will put 6 zeros here. So basically this will become a huge number. In order to reduce this value, what we'll use a prefix mega, because mega can replace these 6 zeros with a simple letter M. Okay, so it is simple to write now. The next is what? Kilo. Kilo is a very common prefix that you use in daily basis, like for example kilometers, for example 10 kilometers. So actually it represents how many? 10 into 10 power 3 means 10,000 meters. Okay, similarly now we have now submultiples. Submultiples are for smaller values. For smaller values, for example, if you have 10 power minus 1, so it's mean it is what? 1 by 10, which is basically equals to what? 0.1. Okay, 0.1, and in powers of 10 it is equals to 10 power minus 1. So that is what deci. This prefix, the prefix that is used to represent 10 power minus 10, 10 power minus 1 is what? Deci, and it is represented by small letter d. You are also used to of it, that is called decimeter. Sometimes we represent the distances in also decimeter. For example, 2 decimeter. So we'll write it like this. So it is actually in meters how many? 0.2 meters. Okay. So 0.2 meters and 2 decimeter both are what? Same. Now we have here 10 power minus 2, this submultiple. This submultiple is basically the prefix we use for it is what? Centi. For example, if we have a length of 5 centimeters, so we'll write it like this. 5 centimeters equals to how many meters? Centimeters, 10 power minus 2. 10 power minus 2 means 5 divided by 100. So now, if we'll write in meters, it will become what? 0.05 meters. Okay. Similarly, if we have what? Milli, for example, if we have 6 millimeters of something, so we'll write it like this. 6 millimeters means 6 into 10 power minus 3. It means 6 is divided by 1000, and which is equals to what? 0.006 of a meter. Okay. Then we have micro. For micro, we have discussed the example before. We can also write microamperes. Amperes is a unit of current. So if I'm going to write like 3 microamperes, it means the current is what? In terms of ampere. Ampere is the SI unit. And if we remove micro, so what number we write? We write the sum multiple 10 power minus 6 ampere. Okay. So similarly for nano, nano represent the prefix, the sum multiple of 10 power minus 9. If we have somewhere written like 20 nanometers, so it means 20 into 10 power minus 9, actually the sum multiple here present, which is replaced by the letter n. Okay, so by using these prefixes, we can make the numbers easier to represent, to write it in a very easy way. Now we have some examples here, practice now. Okay, few of the examples I'll do solve for you here, and the others you will try by your own self. Okay, question number 2. Now we have to represent these multiples or sub-multiples in which form? In prefixes form. First we will memorize these one in the table. One more time we'll look here on the table. Okay. Initially what we have in the form of multiples. First we will consider this one. This one are for the multiples. You can just memorize this what? Kilo, mega, giga and tera. Kilo 10 power 3, mega 10 power 6, giga 10 power 9 and tera 10 power 12. Then the sum multiples are what? Deci, centi, milli, micro, nano. And one is also more pico. Pico is after nano. It is much more smaller than nano. Okay. It is represented by pico, small p, and it is what? 10 power minus 12. This is what pico. Okay. So deci, centi, milli, micro, nano, pico. It is what? Deci 10 power minus 1, centi 10 power minus 2, then milli, micro, nano, pico. These are in multiples of 3. You will see the order 3, 6, 9 and 12. Okay, so these are basically one multiples of 3. Only these are not the multiples of 3. So you will write deci 10 power minus 1 and centi 10 power minus 2. And after the numbers you have, these are what? Multiples of 3, that is 3, 6, 9, 12. And here is also kilo, mega, giga and tera. Also, they are written in the form of multiples of 3. So it is an easy way to memorize it. And then what we are going to solve the problems here. Now, if we have written here what 3 into 10 power 6, I am solving number 2, question number 2, 10 power 6. This means it is what? The positive value multiples. So for multiples, what we have learned? Kilo, mega, giga and tera. Kilo 10 power 3, mega is 10 power 6. So it will become what? 3 mega joules. J for what? Joules. Joules is the unit for energy. Now here we have what? 10 power minus 9. So it is what? Some multiple, that is in negative power. So for negative, what we have learned? Deci, centi, milli, micro, nano, pico. So nano is basically what? 10 power minus 9. So here it becomes what? 8 nano seconds. Similarly, if we look at here we have what? 6 into 10 power minus 6 coulombs. Coulombs is the unit of charge. So this is also the submultiple. So we have learned deci, centi, milli, micro. So deci 10 power minus 1, centi 10 power minus 2, milli minus 3. Then micro is what? 10 power minus 6. So it will become what? 6 micro coulombs. Now these two I left for you. You will solve it. I think you understand these prefixes, how to use these prefixes, why we are using prefixes in order to represent huge values and in order to represent very small values in the form of simple letter. So that's why we use what? Prefixes with the SI units. Okay, hopefully you understand this. If you have any queries, you can ask me. Subscribe my channel. Thank you. Allah Hafiz.